So dear participants, let me welcome you on our session within the CoLINS 2022 conference. We're having natural language processing section, and we have two moderators, that is Olena Levchenko and me, Nataliia Hrytsiv. We would begin with the presentation of Eugene, Fedorov and Olga Nechyporenko with the topic method for recognizing linguistic constructions based on stochastic neural networks. So dear presenters, as soon as you are ready, you're welcome to begin.
Dear colleague, our presentation, method for recognizing linguistic instructions based on stochastic networks. Recurrent networks for recognizing linguistic instructions. Element neural network or simple recurrent network, bidirectional recurrent neural network, long short-term memory, bidirectional recurrent neural network, gated recurrent unit, bidirectional recurrent neural network. Purpose and objectives as a research. Purpose as a research is to develop a method for recognizing natural language structures. Objectives as a research. Analyze existing recognition methods, propose neural network recognition models, choose a criterion for evaluating the F neural network recognition models, propose methods for determining the values of the parameter neural network recognition model. Conduct numerical study. Block diagram of a recognition model based on a unidirectional restricted machine with a recurrent hidden layer. Output neurons, input neurons, visible neurons. Block diagram of a recognition model based on a bidirectional restricted machine with a recurrent hidden layer. Output neurons, input neurons, visible neurons, and hidden neurons. A recognition model based on a unidirectional positive phase. Computational as a state of hidden neurons, negative phase, computational as a state of visible output neurons, the results is vector. Recognition model based on a bidirectional positive phase steps 1, 2, computational as a state of hidden neurons, negative phase step 3, computation as a state of visible output neurons. The result is vector. Criteria for evaluating the effectiveness of neural network recognition models. For training a unidirectional and bidirectional model, the model adequacy criterion was chosen, which means choosing such parameter values or, respectively, the deliver maximum accuracy, matching the model output and the desired output. Graph of the dependence of the recognition accuracy value on the number of hidden neurons. Comparative characteristic of neural networks for recognition. Conclusions. To solve the problem of increasing the accuracy of recognition of natural language structures, the existing methods of a neural network classification were investigated. The studies have shown that today the most effective is the use of recurrent neural networks to improve the quality F. Recognition. F. Natural language constructions, mathematical models. F. Unidirectional and bidirectional stochastic neural networks, restricted Boltzmann machine with recurrent hidden layer, were created, in which, unlike the traditional restricted Boltzmann machine, hidden layer neurons are interconnected. For models of unidirectional and bidirectional stochastic neural networks, methods for identifying their parameters based on contrastive divergences were proposed. In the course of a numerical study of models of unidirectional and bidirectional stochastic neural networks, their structure was determined. The experiments showed that with 200 hidden neurons, the accuracy value does not change significantly, and the selected network gives recognition results with maximum accuracy. The proposed approach can be used in various intelligent systems that use the recognition of natural language construct. Thank you for attention.
Thank you for the presentation. Questions are welcome. Then I have a question. What might be the languages of application? What might be the languages? English, Ukrainian, any other language?
Any language, no, Ukrainian, most Ukrainian and English.
Thank you. Any other questions, participants? If not, then let us move to the second presentation. We kindly invite Andrei Podorozhniak, Nataliia Levchenko, and Vasyl Olinek to present their findings on research application of the spam filters and spammer detection algorithm on social media from National Technical University, Kharkiv Polytechnic Institute. Please try and share your presentation if it goes well.
Yeah, hi, can you hear me?
Yes.
Yeah, okay, let me share my screen. Okay, do you see my screen now?
Not yet.
Okay, let me know when you see this.
No, I do not. Okay. So who is presenting, please? What is
Olena Vasyl.
Vasyl Olenek. So
Yeah,
that is Vasya Olenek, right?
Yeah, right, yeah.
Okay, so let us then.
Do you see my screen now?
I do not. I am sorry. Participants, do you see the screen now?
Yes, all right. All is good.
All is good. Okay, then you're welcome.
Okay, can I start then?
You're welcome.
Yeah, okay. Right. So, hello, all participants. Today, I'll present you an article called Research Application of the Spam Filtering and Spam Detection Algorithms on Social Media. The project was created by me, Vasyl Olinek, Andrei Podorozhniak, and Levchenko Nataliia. So there are a bunch of different social networks and messengers today, which in times of pandemic, coronavirus, and Russian war in Ukraine have taken a really big part of our entire life, especially in our work activities. Besides that, the problem with spam and spammers is the most relevant than ever. The count of spam in the work text stream is continuously increased. Under spam, we understand the text content that it's not necessary in the particular text stream. In case of spammer, it's mean the person that is sending the spam messages in his or her own purposes. The project was designed to solve the scientific and applied problem of detecting spammers and identifying spam messages in the text context of any social network or messenger using various spam detection algorithms and spammer detection approaches. We have implemented 4 algorithms. The first one is the algorithm using naive Bayesian classifier. The second one is the support vector machine. Then it's multi-layer perceptron neural network and convolution neural network. So on this slide, you can see the diagram that displays the percentage of spam and email traffic in 2021. Sorry, 2020. Thanks to various anti-spam and spammers algorithms, the share of the share of spam in global traffic in 2020 was down by 6.14% when compared to the previous reporting period. The ratio of the spam is 50.37%. So let's start and firstly discuss what is the spam actually. Spam is the mass mailing of correspondence of an advertisement to people who have not expressed the desire to receive it. The examples of the spam can be advertisement, phishing, Nigerian emails, mass mailing of letters with religious content, and so on. However, the surest way to deal with spam is to prevent spammers from getting your email address, but it's not always the case. The deal with spam, we have to deal with spam, we have auto spam detection software that is also called anti-spam filters. They can be applied by the end user or on the servers. This software has two main approaches. The first one is when the content of the message is analyzed, and based on the algorithm, decide whether it's spam or not. If the message classified as a spam, it can be marked or moved to another folder or even deleted. Such software can run both on server and on the client computer. The second approach is when it classifies the sender as a spammer without looking at the text of the message. The software can only work on the server which directly receives the messages. With this approach, it's possible to reduce the cost. The money is only spent on communicating with spam mailing programs and on contacting other servers. As a training data set, we choose a data set of spam messages from Kaggle, SMS spam, a collection data set, and spam mails data set. But the data set of messages from a particular company can also be used to train the algorithm. To implement the spam filtering algorithm, we use Python 3.6 programming language and PyCharm. We used four most popular spam recognition algorithms: naive bias classifier, perceptron, convolution neural network, and support vector machine. We get the message on this slide. You can see the diagram that displays how the algorithm actually works. So we get the message from the user, in our case from Telegram user. Then, if the user is unknown in our system, we add him to our database with all of the users of the application. After that, we analyze the message using all of the existing algorithms that we have implemented, passing the result from all algorithms to the majority algorithm. We calculate the spam percentage of the message. Then the result of the majority algorithm is passed to the spam analyzer, which decides if the user that sent the message is spammer or not, based on the provided spam percentage of the message and two last predictions. So to identify the user as a spammer, we analyze his three last messages. And if the average spam percentage is bigger than specified threshold, we recognize the user as a spammer and put his ID to the database with spammers. So as a threshold, we choose the value of 0.95. Yes, and as you can see, we get the spam percentage and the message itself from the majority algorithm, and based on the received message and the last two messages of the user, we determine if it's a spammer or not. If a user is a spammer, if the user is in the spammers database, his messages are being deleted without even analyzing them, or just block the user so he's not able to send the messages. anymore. Only the manager of the application is able to remove users from the spams. On this slide, you can see the general scheme of the algorithm. But let's move on to the tests. So also in addition to the usual accuracy metrics for evaluating certain algorithms, we used F1s for accuracy is the ratio between the currently classified samples to the total number of samples. Nowadays, it's the most used metric of classification performance. And here you can see the result of testing the developed project on the SMS spam collection dataset. And on this slide, you can see that the result of the test on spam mails dataset. As you can see, the efficiency of our algorithm has fallen a little bit, since when developing the algorithm we used the first data set and all optimization were tuned specifically for it, but it's still pretty high. Yeah, let's move on to the conclusions. Yeah, as a part of this research, the scientific and applied problem determining spam in the textual context of the social network messengers was solved by the example of Kaggle SMS spam collection dataset using chatbots in popular messenger Telegram. Besides that, the basic spam detection algorithm were analyzed, and the one was implemented in the application. So yeah, first of all, we consider the relevance of spam detection, possible problems due to the spam intervention. Then we also consider the basic method of spam recognition. We consider the basic method of spam detection, and it was developed a program to filter spam and spammers detection in the messenger Telegram that uses 4 implemented algorithms. For spam recognition, proposed complex majority algorithm. All of the text traffic is also checked for the spammers. Yeah, and on this slide, you can see the example of how the algorithm works. Yeah, so let me demonstrate that. Yeah, so we send the 3 spam messages in a row, and after that, the user is considered as a spammer, and all of his messages are being deleted. And we just to demonstrate, to send the message that the user is a spammer, so we can understand that the algorithm works. And yeah, that's all. Thank you guys for your attention.
Thank you for the presentation. Questions are welcome. Segun, you're welcome.
How many layers did CNN have?
The CNN has 3 layers.
Thank you.
Any other questions? If you come up with a question, you may also use the chat within the program, right? So that later on the presenter will have the chance to answer. Now we invite Sergey Orekhov and Henadii Malyhon with the topic method for synthesizing the semantic kernel of web content. Do we have the presenters from National Technical University Kharkiv Polytechnic Institute? The presenters Orekhov and Malyhon. I believe the presenters might join the session later on. And now let us move to Alexander Murushko, Nataliia Hrytsiv, and Vasil Tesluk with our topic remote selection of stuff based on socionic analysis of social network content. The team is from Lviv Polytechnic National University. So who would present? So you're welcome, Olexander Morushko, Natalia Hrymitsa, and Vasil Tesluk.
Dear colleague, you can see my presentation.
Dear participants, do you see the presentation?
Yes, yes.
Yeah, we can see the presentation, but the main problem that this is not from the beginning. I think this is slide 11 like this. That's why better from the beginning.
So is it Natalia Hrymitsa presenting?
Just a minute, please. Please, can you see my presentation?
No, the same situation, I think better for you, open PDF file, because you open PHP file, and when during the conference you open PHP file, this is heavy file, not possible to move the presentation. That's why I try to close this PHP file and to open PDF file. Because presentation doesn't move.
Dear participants of the conference, let me present the result of the research on the topic remote selection of staff based on socionic analysis of social network, carried out by the group of the scholars of the Lviv Polytechnic National University, Alexander Morushko, Natalia Hrymitsa, and Vasil Tesluk. In recent years, we have faced the problem when interpersonal and organizational communication, including live communication, is quite limited. Therefore, the task of organizing and supporting business communication, selecting candidates for vacant position and creating capable work teams remotely has become very important. One of the ways to find the best candidates for vacant position and create effective teams remotely in such condition of limited access to information about the participant themselves can be socionic diagnostic of content from social network, including photo content and text messages. Foremost, the task is to determine the sociotype of applicant using the Young basis method of selection of socionic types. Everyone perceives, process and transmits information differently. This process depends on the location of mental functions, their agility and signs of functions as shown in the figure. Based of in this slide. And based on Jung's coordinate system and the setting of conscience, extroverted, introverted, Aušra Augustinavičiūtė singled out 16 socionic types, 4 of which are formed at the intersection of rational logic, ethics, and irrational sensory institution coordinates functions. In the process of visual verbal determination of the sociotype, we can consistently determine which of the 4 dichotomous features of Jung's is leading and coordinately determine the sociotype of the subjects. Tables from the first to the fourth show the visual signs for identification. In these slides, fifth table show words markers for diagnostic socionic functions. And in this slide, you can see an explanation of the table and we presentation in this slide, intertype relationship, psychological distance. In this slide, you can see an explanation of the table. Example of application of socionic analysis. Example 1, user Daria Norikova. From the above photo, we can conclude that the user is a logician because the upper part of the face is not round but rectangular. Also, with high probability can be said about extraversion, dynamic gnosis, and the desires to be the center of attention. The shape of the face is pentagonal, which indicates intuition. And finally, the shoulders stretch, the figure is tightened, that is, it is rational. We can conclude that Daria corresponds to the sociotype of a logical, intuitive extrovert. We also conducted a verbal analysis of Daria Norikova's text messages. Analysis of the text messages show as first of all extraversion, very dynamic presentation of information, and intuition sensors most likely will not risk going on vacation in the mountains without their own equipment. The ability not to get confused and use the situation to your advantage indicates the presence of business logic. It follows that the program function is business logic at creative, the intuition of possibilities. So before us is a logical intuitive extroversion. The next slides show the results of visual and verbal analysis of the content of Pavlo Hood. Using the same method that in the first example, we determinate the Pavlo Hood belong to the sociotype of intuitive logical introvert. In this slide, we can see the result. Psychological compatibility. If Daria and Pavlo had to work in a team, the intertype relationship is a mirror image. Both belong to the representatives of the Z quadrant. The psychological distance is minimal the first. This is a very comfortable relationship, provided that there are no elements of the direct competition. Therefore, it would be better for both of them to have the working group they belong to headed by a third persons, preferably in ethics from the Z quadrant. The analysis of the obtained results you can see in these slides. And so proper and appropriate use the socionic analysis method can minimize the risk of remote recruitment, and equivalent specialist can teach any managers in a relative short period of time the basic element of applying this method. It is enough to correctly analyze the visual and verbal information available from social network. Thank you for your attention.
Dear participants, questions are welcome. Then I have a question. So thank you so much for your presentation. What is the prospect or the perspective development of your findings? Nataliia, what do you plan to do in future with your research, with your results?
In future, our result we can for different organization for distance recruiting and for organizing teams work.
Thank you so much. Any other questions? If not yet, once again, you have the opportunity to come up with your question and address it to a specific presenter within the chat in here, right, within the section. Then let us move to our next presenter. We have the team of presenters on evaluation of Veda and multilingual sentiment analysis for opinion analytics using graphical illustrations. Thus, we have a team of presenters: Taiwo, Olaleeye, Peter Ugege, Olalekan Okewale, Olatunji Akinade, Segun Akintunde, and Chidi Akparanta. from Computer Science Department, Federal University of Agriculture, Abeokuta, from Nigeria. So who would present on your behalf, please? Dear scholars, Taiwo Olaleye, are you ready to present? Dear participants, do you hear me, or are we having some technical problems? So we are having Sergey Orekhov joining the meeting. Let us give it a second. Then while the participants are joining our meeting, so let us move to our next presenter, so our next topic. We have Larisa Savitska and the company from Simon Kuznet Kharkiv National University of Economics. That is about world-to-vec model analysis for semantic and morphological similarities in Turkish words. So do we have? Who is presenting? Would you introduce yourself on behalf of?
So I will introduce Larisa Savitska. I'm going to show our presentation.
On behalf of Turgun Subay, Nataliia Vnukova, Irina Bezukla, and Vasil Pivovarov, you're welcome.
Yeah. So good day, dear participants of the 6th International Conference, Computational Linguistics and Intelligent Systems. I'm Larisa Savitska. I'm head of the Department of Foreign Languages and Cross-Cultural Communication from Simon Kuznet Kharkiv National University of Economics. And here you can see the team of the people who we are working to. This is Turgut Subay, Nataliia Vnukova, Irina Bezukla, and Vyacheslav Pivovarov. So today in my presentation, I'm going to speak about word-to-vec model analysis for semantic and morphologic similarities in Turkish words. This study presents the calculation of the similarity between words in Turkish language by using word representation techniques. Word-to-vec is a model used to represent words into vector forms. It is one of the latest techniques developed by Thomas Mikhalov to study high-quality vectors. The word-to-vec model is formed using articles from Wikipedia Dumb Turkish Service as the corpus, and then cosine similarity calculation method is used to determine the similarity level. The open source Python programming language and Gensim library are used to obtain high-quality word vectors with word-to-vec and calculate the cosine similarity of the vectors. Continuous back-of-words algorithm is used to train high-quality word vectors. The cosine similarity values in the results are derived from the weight dimension value of the word vector dimensions. The window size 10 and 300 vector dimension configuration are taken. The corpus is trained in 5 cycles, epochs with the same parameters. The Turkish corpus contains more than 161 million words. The dictionary of words, unique words obtained from the corpus, is more than 367,000. Such a big data gives us an opportunity to conduct high-quality semantic and morphologic analysis and arithmetic operation of the word vectors. Thomas Mikhailov and his team conducted the research on training word embeddings by using word-to-vec vector model representation from English corpus. Last year, we did the research on training word embeddings by using word-to-vec model representation from Ukrainian corpus. Dmytro Cheklinsky used LexVec, word-to-vec, and GlavVec model representations to training Ukrainian word embeddings. Andrei Romanuk suggested training Ukrainian word embeddings with word-to-vec, fast text, and Muse model representation. Victoria Vysotskaya did comparative analysis for English and Ukrainian text processing based on semantic and syntactic approaches. Word vectors obtained from the general context Turkish corpus used word-to-vec models are clustered and related in terms of semantic relations of Turkish words. As a result of training the word Istanbul, the city name, the first 5 word vectors with the closest cosine similarity to the vector Istanbul are shown below. Istanbul and Ankara vectors are clustered together referring to semantic relation between words Istanbul and Ankara, 2 important cities of Turkey. As for the vectors such as Bursa and Trabzon, they are clustered together referring to the lexical paradigm of the word represented in the other important cities names of Turkey. The word vectors Üsküdar and Yeni Bosna are clustered together with the word vectors Istanbul because words Üsküdar and Yeni Bosna represent names of 2 important districts of Istanbul. Arithmetic operations of the word vectors and semantic relationships between words. The first 5 word vectors with the closest cosine similarity to the result vector of Karl minus Erkek plus Kadin operation are shown below. The result obtained from the Turkish corpus is similar to the result obtained from the English corpus. The vector Kraliçe belonging to the word Kraliçe is in the Turkish equivalent of the word queen, and the closest cosine similarity, cosine-like vector to the result vector from the operation. This operation is the replacement of the gender characteristics in the word Karl, which expresses nobility. In terms of the word meaning, the result of the process is the word Kraliçe. It is seen that the word meaning is compatible with the result of the adding and subtracting the vectors. The word Kraliçe is defined as the wife of the king or the woman who rules the kingdom. In the current Turkish dictionaries represented by Turkish Language Association. Another example below are the first 5 word vectors with the closest cosine similarity to the result vector of İngiltere minus Londra plus Ankara operation. This operation is the transaction of the relationship between countries and cities or their capitals. The vector obtained as a result of Turkey, the first vector among the cosine-like vectors. The process and result vectors are compatible with the result of the adding and subtracting vectors. Formal clustering of Turkish word vectors. Turkish language is an agglomerative language. The general feature of agglomerative languages is that word roots are kept constant, suffixes and inflections with the various functions are added to the roots by adding different suffixes to the roots of the word. New words are derived and the vocabulary of the language is formed in this way. All the changes and developments in Turkish are based on the root suffix combination. The first 5 word vectors with the closest cosine similarity to the vector gitme are shown below. The word vectors clustered like a cosine are vectors belonging to the verbs in the form of infinitive. The clustering of the word vector is related to the formal feature, infinitive suffix me. It is a formal derivation of the word good with the suffixes me or ma. Arithmetic operation of the word vectors and morphology between the words. The first 5 word vectors with the closest cosine similarity to the result vectors of gitme minus git plus gutur operation are shown below. According to the results of operation, the obtained vectors clustered like a cosine, referring to the formal feature infinitive suffixes me and ma. So as for the conclusion and our future work, the research analysis made in terms of semantics proved that the word vectors accuracy would represent clusters according to semantic or formal relations with the words they belong to. The research analysis made in terms of morphology proved that the word vectors are clustered and indicates a high structural level of construction of the Turkic language. Our future works on this topic will focus on constructing semantic maps of various subject areas and expanding queries due to associative connections. Thank you for your attention, patience, and interest in listening to me. If you have any questions, please feel free to ask them.
Thank you for the presentation. As the participants who would like to address the question, you're welcome.
May I ask a question, if you please? On your slide, you showed vectors with many numbers after point. Do you try to check how sensitive numbers from your corpus of texts? Maybe one or more word will much change these numbers, and important only maybe 3 numbers after point.
So thank you for your question, because reality, when you're going to train English corpus, I think if you're training English corpus, sometimes it is enough only 3 or 4 numbers after the dot or after the point. But reality, we did the same research, and we tried to train Ukrainian words and Ukrainian corpus. And after that, it was very important, and we investigated this, that we need more high quality vectors, and we need more numbers after point or dot, because sometimes you start to train the word, and obviously you can see in the results that some words are more close, but machine shows different results. That's why this accuracy, I think, especially in Turkish, in Ukrainian language, is more important than in English. Maybe for English, even I know that for English it's enough only 3, 4, 5 like this.
Okay, thank you.
Any other questions? If not, then we would once again address the reporters from National Technical University Kharkiv Polytechnic Institute. We talk about Sergey, Orekhov, and Henadii Malyhon, who experienced some technical problems. So are you ready to present? Yes, you're welcome.
Yes, we are ready.
Glad to have you with us.
Yeah, okay, thank you. So let's share our screen. Okay, dear colleagues, let me present the results of our scientific work performed during the last 10 years. The presentation structure has been depicted on the second slide. The development of the internet technology led us to a new technology, named virtual promotion of a product. Its main feature is to create a logistical promotion channel in which a special message is placed. The purpose of creating such a method is to attract a potential buyer who connects to the channel. We call it such a message a semantic kernel. Slide number 3 is like a sample. What is a semantic kernel? It is a set of keywords which annotate the real definition of a product or a service in virtual space. Its pattern and sample are depicted on this third slide. A semantic kernel is described as annotation of a piece of knowledge. Usually, at a very moment, we are embedding the kernel to website content. As part of our study, semantic kernels from a numerical website were obtained. For this, the pattern presented on the slide number 3 was applied. From the point of view of search engine optimization, the semantic kernel is a database of keywords, word forms, and morphological forms that most accurately characterize the type of activity, product, or service that promotes a given web resource. Therefore, the semantic kernel should be considered as a set of keyword forms. We propose to present it as a semantic network. In the paper, we assume that we have a semantic network where the vertices are keywords. Such keywords can belong to one of 3 classes: concept, object, or action. It is suggested to consider that the semantic kernel is a semantic network of propositional type. Keywords such as concept and object are considered as a network nodes. These 2 classes form the rules that describe the knowledge of the product in the format what, when, where. That is what we sell, when the product is available, and where you can buy it. In the same form, it is possible to make out the description of needs of the buyer. Using these assumptions, we built a mathematical model of the semantic kernel as a model of the text about the product or need. As input, we have a text document, D, which can be written in any languages and presented as an HTML construct or plain text. Slide number 4. Whereas with index I, it is a sentence that is a part of product D. We believe that there will be n sentences in the document. The sentences consist of a set of words and separators of 2 types. The first type with index IB is separators between words. The second type, separators with index I key, is sentence separators between themselves. In our case, we will assume that the set of characters separators with index I key is unimportant, but the set of characters with index IB will be transformed into a set of connection between nodes of the semantic network. We have 3 types of connection: is a part, is a type. Then let us move on to define candidates, words that will be included in the semantic kernel. Candidate is a word or phrase that meets the criteria and is potentially in terms of a specific subject area. Let P be a set of candidates for the semantic kernel. The elements of this set are words V with index I and phrases P with index J. Next, define the structure of the phrase, the set of P with index J, where J is a number of the phrase, but C is a number of the words in the phrase P with index J. Z is the maximum number of words in the phrase. Usually Z is equal to 10. In the paper, we propose to use the statistical metric M, bigger one M, in order to compare the elements of future kernel. Having all these requirements, we can formally formulate the problem of semantic kernel synthesis. given a text body that describes the product or the needs that it covers, it is necessary to find a set of pairs. Each pair is a word or phrase and value of a statistic matrix. As metric M, we propose to use special matrix C-value. Slide number 4. Thus, the solution of the problem of semantic kernel synthesis describes the construction of word metric pairs. We present a method of obtaining such pairs. Slide number 5. The text body is supplied as input. Within the development method, there are two cycles. The first cycle operates with sentences as phrases, and the second cycle works with the selected sentences and selected words from them. The first cycle leads to a construction of a table of candidates in the form of phrases, and the second cycle allows us to build a table of candidates in the form of words. At the same time, the metric we propose it also us to take into account the occurrences of the selected candidates' words in the selected set of candidates' phrase in order to eliminate duplicates. As a result, a set of phrases and words of candidates for the semantic kernel is formed. The action diagram demonstrates the algorithm or the method for synthesis. A set of semantic kernel, slide number 6. The software implementation of the proposed synthesis method is based on the assumption that there are two software components. Slide number 7 and slide number 8. The first, slide number 7, describes the method for synthesis, the semantic kernel. And the second component, slide number 8, is needed to present web content as a semantic network. The first component is made according to the classical architectural pattern model view controller. The algorithm for applying the components is presented in the form of sequence diagram, slide number 9. At the moment, the proposed software components are being implemented for one of the web resources in the United States. The proposed synthesis method made it possible to review the effect of aging of the semantic kernel. This effect is consistent with the classical marketing theory of the product life cycle. That is, the proof of the correctness of the study of the phenomenon itself was revealed. The semantic kernel of the web resource is shown on slide number 10. Among the obtained results of scientific novelty are the following. For the first time, the problem of synthesis of the semantic kernel of web content is formulated, and the method of its solution from the standpoint of system analysis and method of artificial intelligence is described. For the first time, the metrics for estimation of semantic kernel on the basis of estimation of the text case of web content are offered. The method of presenting the semantic kernel as a semantic network was further developed. The direction of further research will be the implementation of this algorithm based on JavaScript libraries. Thanks for attention.
Thank you so much for your presentation. Questions are welcome.
Can I ask a question? Such semantic kernel for each other project should be created by hands, no automatically, or every time it's the same?
No, at the moment we have the software where inside which software you can put the web content in the form, for example, HTML text, and then generate this semantic kernel to see the effect. And then
Uh-huh.
using these semantic kernels, you can receive, for example, not only one version of this such kind of kernel or set of different versions, and you can use them in order to see the effect of changes during the, how to say, software development cycle, how this kernel influences on the search engine optimization problem. I have showed this effect on this slide number 10. We have
each time different kernels for different projects.
Yes.
Mm-hmm. Okay.
Especially for this website here. This is website stored in server in United States.
Okay. Thank you.
Do we have any other questions? Thank you once again for a very informative presentation. Now let us turn our sights to our next presenters. Thus, we have Taiwo Olaleye. Would you please? Okay.
Yeah.
Hello. Then let me present the topic: evaluation of whether of multilingual sentiment analyzers for opinion analytics using graphical illustrations. And we have the presenters from Computer Science Department, Federal University of Agriculture, Abeokuta, Nigeria. And you are presenting on behalf of a team of 4 authors, right? You're welcome.
Yes, please. Thank you. Yeah, thank you, everyone, and good day. My name is Taiwo Olalekan. And please, can you see my screen, please?
Yes, we do.
I don't know if my screen is okay. Thank you. So I'm presenting on behalf of my team on the topic evaluation of VEDA, a multilingual sentiment analyzer for opinion analytics. And the essence of this study is to discover lingual sentiment analyzers on textual corpus, to especially textual corpus that discusses football competitions, because VEDA and multilingual has been deployed for several research domains. Hardly would you find literature discussions textual on VEDA and multilingual. This structure from introduction down to the conclusion in quick succession. Natural language processing is a use case of artificial intelligence where it helps in understanding, it helps system several application areas from topic modeling to word embedding, sentiment analysis, and all of that, with several state-of-the-art, most especially, it helps with opinion mining, which tries to extract emotional tones and sentiments that are expressed in natural languages, and which has been applied in several research domains as well. And the two variants of sentiment analysis tool are VEDA and multilingual that we have adopted in this study, which will be evaluated on textual corpus extracted from a football competition between Nigeria and 2 other African nations during the just concluded African Nations Cup. So this study is actually motivated by the functionalities offered by natural language processing, and to determine the peculiarities of VEDA and multilingual analyzers, sentiment analyzers on textual corpus extracted from discussant of football themes. And it is also further motivated by the fact that the football is a very popular competition sport that is recognized in over 200 countries of the world. So it generates a lot of discussions on social media, which actually also motivated this study. So we have summary of some selected literatures. A lot of literatures were reviewed, and some of them that has also done similar works in this area, like Olalekan et al., a recent paper, who used a survey data to evaluate two variants of topic modeling algorithms to unravel discussions and themes from the data. And then a work was also done way back on media feedback by using perception model to extract feedbacks from sport lovers. In 2021, Nechyporenko et al. Worked with tweets and used the methodology of Twitter sentiment analysis to extract emotions expressed in football as a result of football competitions, to extract emotions and actually understand the sentiments of people about the players. And just as Facebook comments and tweet conversations have also been used severally by Marina and Vedran and Alaufi and Sadiq using the sentiment analysis tool, or in the other instance, sentiment classifier, by combining sentiment analysis tool with a machine learning model. So observations from literature, we realize that there is prevalence of manually collected corpus, or some literatures, most literatures target specific users on social media to extract their opinions. We also discovered that most of these studies have specific analyzers in mind without much work being done on a comparative analysis when we talk of football-related textual corpus. So the objective of this study is cut out, and that is to now do a comparative analysis of Veda and multilingual sentiment analyzers on football textual corpus for sentiment analysis. The conceptual framework, this study was implemented with Orange data mining toolkits, where several processes were involved. The tweets, we had two data sets of tweets, one from the Nigeria versus Tunisia football match that was played less than 2 months ago, and the other was from the Nigeria versus Guinea-Bissau match. And those were acquired through the Twitter API, and then several processes were done until result was analyzed. So the first stage of the framework is corpus acquisition, the tweet acquisition. Like I mentioned earlier, the Twitter API was used, and 141,371 textual tweets was acquired for the Nigeria-Tunisia match, and 127,072 corpus, unigram corpus, was acquired for the Nigeria versus Guinea-Bissau match, and each of them returned 1,000 tweets each for both matches. Then the textual corpus were preprocessed to in readiness for the sentiment analysis. They were converted, the two, Nigeria versus Tunisia and Nigeria versus Ghana, 1,000 each, were converted to lowercase. Elimination of elements were taken away, after which tokenization was done to reduce each 1,000 documents into a unique tokens that makes up each of them. And filtering was also done to remove articles, prepositions, and conjunctions that do not have discriminative abilities in the analysis. Then topic modeling was implemented to at least extract themes, topics from the two database, and the latent semantic indexing topic modeling phase to extract topics. Now, the Veda-based lexicon analyzer is valence-aware dictionary and sentiment reasoner based lexicon analyzer was the first to be deployed for the analyzers that deals with feelings, especially, and it's easily afford to sentiments produced on social media, easily deployed and mostly deployed for social media extracted purpose. And it relies on a dictionary that maps lexical features to emotion sentiment scores. For each 1,000 documents belonging to the two different databases, the Veda-based analyzer would compute the sentiment score for positive sentiment, negative sentiment, and neutral sentiment for each of the 1,000 documents belonging to each of the two databases, and a compound sentiment, which is the overall determinant of the sentiment expressed in the particular tweet. And then the multilingual analyzer is actually a deep learner-based framework that deploys either word to vectors and then produce an output layer that is deployed for the eventual analysis. And the result is hereby presented. For the Veda-based analyzer, the most positive sentiments are hereby presented, and with their various neutral, negative, and positive polarities presented. It is observed, actually, even from the negative and the neutral polarities, that most of the expressions expressed are more of positive and neutral than negative. And then the multilingual also presented the most positive of its intakes, and they are hereby presented depending on the expressions. And it could be observed from the two results that the Veda-based analyzer actually dealt more on tweets with longer phrases, tweets of longer phrases, unlike the multilingual analyzers that returned most of the returned expressions are of shorter phrases, 3-word expression, 4-word expression, as can be observed from here. And it is also observed that the multilingual analyzers attracts more of tweets or discussions that are done with local language, because most of these tweets are done with a mix of English and what is called pidgin language in Nigeria. Pidgin is a localized version of English language that uses notations, local notations to express their feelings. So the multilingual analyzer tends to analyze more of expressions, tweets that are composed with the pidgin language, English pidgin language, unlike the Veda analyzer. And the word cloud is presented for the Veda most positive sentiments. They are hereby presented with words with good, best, small, beautiful, has more weights than some other unigram expressions. And the multilingual analyzers was also analyzed through the word cloud, and the result, the most weighty words are hereby presented in this word cloud. And the result of the topic modeling also for
Connection lost?
I guess so. So let us wait a moment, then. lost and the presentation disappeared from the screen now. Okay. Let us meanwhile invite our next presenters. That is Lilia Kharchuk, Oksana Litvin, Oksana Makidyuk, and Irina Mentenska, just to prepare, right? Just a moment, and suppose in a couple of seconds the previous presenter does not appear, then you will be asked to begin. Just a second.
Just a minute. Can you see my presentation?
Yes, you're welcome.
Okay. Welcome to our presentation. The theme is practice of complaints of punctuation rule in internet communication, made by collection work of Oksana Litvin, Lilia Kharchuk, Oksana Makidyuk, and Irina Mentenska. Statement of scientific problems. The problems of complaints with the rule of punctuation in online communication made of the base of Google Forms through questionnaires is available materials for the linguistic as they show the linguistic specific of a particular historical period. The energy of the research is due to the need to improve punctuation literacy as the base of linguistic and cultural heritage of the people. The novelty of the work is that for the first time a new course base has been developed which allows to consider students' discourse at the level of the synchrony and clarify the expedience or inexpedience of punctuation requirements in internet communication in terms of the formal business and conversation style. The scientific significance of the work was determined by the subject of research, as the difference is complaints with punctuation standards by students of humanities and technical specialties was compared. The interaction of formal and informal style is shown. One the example for response textual materials directly from the student environment is involved. The aim of our study is to establish compliance on punctuation rules. In written online communication, depending on the type of communication, business or informal, to find out the frequency of punctuation error, type of most common punctuation error, to suggest solution to punctuation problem. Active introduce of technical means affect the transformation of form of communication. Diversification of punctuation for the use of verbal and non-verbal means of communication leads to the following hypothesis. The first, Modern communication, internet environment is a new kind of business communication. And the observe of punctuation rule help to the logical and syntactically divide statement into the separate semantic elements which allow to achieve the goal of the communication. The second, deviation from the punctuation norm of modern literature language is the main feature of informal communication of students in the internet environment. Punctuation marks that help the author to accurately or figuratively depict object or phenomena of the objective word. The material of the research is questionnaire of students of Lviv Polytechnic, in which they indicate their attitude to the rules of the punctuation. The Satan and next slide show to study of our research and different method in our research. Result of research, all type of the norms that are typical for the internet communication, in we take into account the lexical norm has undergone the great change during impersonal communication as English, surgic, slang, popular in internet. As for the orthographic norm, it's evolution cast only by the actual linguistic fact. Evolution of punctuation, which is the subject of the description change of the understanding of the text and leads to a lack structuring and forms a communicative barrier, change the verbal assessment of the text. Experimental result of the discussion. The study was conducted on the basis of Google form through a questionnaire survey of the 247 respondents, students of Lviv Polytechnic, of 17 under 20 years. The questionnaire includes 21 questions, among which the dominant for us is written formal, informal communication and punctuation motivation of response related to internet communication. To motivation the relevance of the work, we have identified to the following block. First, the importance of punctuation marks that show two boundaries of thought. Second, the use of punctuation mark, dots, commas, colons, dash in accordance with the rules of punctuation. Response. Among the response, 47.5% are students of humanities and 52.5% technical specialties. For most students, 241 people Ukrainian in their mother tongue. For 6 people, their mother tongue is Russian. In everyday speech in the family with friends, 13 students speak Russian. 1 student speaks the local dialect. 9 Surgic. 1 student speaks Ukraine with parents and Russia with friends. 8 students speaks both Russia and Ukraine. 215 students speaks only in Ukraine. Linguistic and extra-linguistic factor in punctuation. Among the extralingual factor, non-complaints of punctuation can be explained by the speed for the written lack of eyes contact, which lack shines impossible. Among the intralinguistic factor, non-observed of punctuation is possible due to the low level of knowledge of the language, lack of automaticity for typical situation. The slide 17, 18, 19, 20, those some of the asked question and the answer show in present age. Students were asked if they use punctuation mark that fix the end of the sentence and other questions. Conclusion. Conclusion, the result of the questionnaire prove that the hypothesis about the need for punctuation rule in informal business communication and the hypothesis about the deviation from punctuation rule in informal communication in typical for the students' environment. Regarding the set assumption to the grammatical function of punctuation, it turned out the percentage of people trained to put punctuation mark was unexpectedly low. Thank you for attention.
Thank you so much for your presentation. I would allow myself to ask you 2 questions and then some other participants. And that's how can you use your research in practice? And what prospects can your research have? Thank you.
I think the information can be used for the computer spelling application, for the improved computer spelling application. Prospect of the research in this area include conduction similar survey among different age group, include middle age and older response, which will allow to compare the result of the punctuation. We also consider it's possible to compare it to the result of the survey of the response from Lviv Polytechnic University and other Ukraine and foreign university to see the geography of the issue.
Thank you so much. Dear participants, do we have some other questions to the presenter? Thank you. Then we would kindly invite Taiwo Olaleye once again. Taiwo managed to rejoin us. And I believe the connection was lost once again. Okay. Then let us move to our next team of presenters. Krystyna Becyshin, Зоряна Галаджун, Наталія Кунанець, Оксана Гопчур, and Nataliia Veretennikova. You are invited to present the topic on innovative vocabulary with the prefix "nt" in the language of Ukrainian online media in the time of COVID-19 pandemic. You're welcome.
Thank you. So I would like to present our research. And first of all, the aim of the study is to highlight the innovative vocabulary with the format "nt" anti in the language of Ukrainian online publications of the period of COVID-19 pandemic, as well as to study its semantics and pragmatics of use. There are several tasks of our study. First of all, to study the basic meanings given to these neologisms, to investigate the lexical compatibility of words with this prefix, and to trace the possibility of machine semantic analysis of content with this prefix during the COVID-19 pandemic period. The object of the research is text of online publications of this period containing words with the prefix anti, and the subject of the research is innovative vocabulary with this prefix, its semantics and connotative components of meaning, lexical compatibility, pragmatics of use, expressiveness, and tonality. During our research, we have used the following methods. And the first one is descriptive method, and it made it possible to provide an exact and complete description of innovative words with the format anti, and to systematize and invent the factual material. The techniques of external implementation were used to establish a connection with extra-linguistic phenomena, among which the key ones were sociological methods and in particular, the reception of semantic groups of words related to this topic. The next one is comparative methods. It helped to reveal common, identical, and different features in neologisms with the prefix anti and the base words. Next one, structural method. The use of it is based on the understanding of language as a holistic structure in which all the elements are interconnected within a system of linguistic relation. Among the methods of this structural analysis, distributive analysis allows to distinguish the meanings of analyzed neologisms. Also, the method of component analysis allows to determine the semantics of analyzed innovations, and the method of functional analysis determines the functions of such words in the language of online publications. The productivity of such neologisms is due to two groups of factors, lingual and language resources, expressive possibilities of words with this prefix, and some tendencies to complicate language structure and verbal differentiation. And speaking about extralingual factors, it is emergence of new realities that require nomination, and presence of disease prevention system and polar views on disease prevention measures. In neologisms of the COVID-19 period, the prefix anti has some meanings, positive meanings, negative, or it can have both positive and negative meaning. Speaking about positive meaning, it first of all, it should counteract, prevent something that is nominated by the creative base, as for example in adjective anti-coronavirus or anti-COVID, and given the negative connotations of the name of the disease, the prefix anti in these adjectives has no negative sense. It acquires positive meaning. Next, it has the meaning of hostile to what is called by the creative base, as in the adjectives anti-quarantine or anti-mask, and it also can be noun anti-mask, and these words quarantine and mask are perceived by some speakers positively as a means of disease prevention, but at the same time other speakers think that these words are negative as one of the meanings, one of the means of some restrictions. So in this case, this prefix can have positive and negative meanings. And the last one, an example is like anti-record, and this formant anti is attached to words with positive meaning, and new words acquire the opposite negative meaning and have negative connotations. Furthermore, this prefix used to create neologism adjectives and neologism nouns. In adjectives, it is realize a meaning which must oppose, prevent what is called by creative word, as in neologism like anti-coronavirus, and next meaning is hostile to what is called by creative word, for example, anti-quarantine, and opposite to what is called by creative word, it can be anti-mask. In nouns, it realizes the meaning opposite to what is called by creative word, and as an example, it can be anti-record. The using of neologisms of this prefix in some combinations can be even illogical, and as an example, it can be headline of the article, new anti-coronavirus record in Kyiv. The number of new cases has doubled in a day, and the meaning of this prefix determines the perception that the record was intended to combat the coronavirus or showed a sign of something opposite to the coronavirus or hostile to it. The sentence refers to a significant number of identified cases of the disease, so it was appropriate to use an adjective without the prefix anti, but the expressiveness of the text would remain unmotivated. Next example you can see on this line. There the headline of the article also contains a logical error, and this report should be understood as information about police measures against quarantine, for example, a protest against state measures to prevent COVID-19, which is a priori impossible given the functions of the police as a state structure. Connotations of neologisms depend on lexical combinations. For example, lexical compatibility of adjectives anti-coronavirus and anti-COVID includes nouns of the following lexical and semantic groups. All of them are on this slide, and these connotations of neologism adjectives are determined by meaning of a denoted noun. Positive connotations of noun determine positive connotations of such a neologism, and negative determine negative connotations. And for example, in combination with noun quarantine, adjective anti-COVID will have a positive color for those who positively perceive such measures, and negative for other people. And the combination with the word restriction gives a negative color to the neologism, which is reinforced by the verbs such as to cancel, to remove, or adjectives like severe. The connotations of nouns neologisms with this prefix are determined by the meaning of the prefix anti, and the meaning of the creative word, and the meaning of other words that can be used in this sentence. For example, the connotations with the word anti-mask enhances the lexical compatibility with adjective, like it is the name of the signs of antisocial states of a person. As an example, it can be drunk, anti-mask, with verbs like names of actions that indicate antisocial aggressive behavior. As an example, to boot a journalist, or to shoot in the head. And the lexical compatibility of this word testifies to its inherent negative connotations, shows a bright negative tone, and using the prefix anti to create nouns, as in the neologism anti-mask, is a reflection of such social polarization. The research of the text with the prefix anti was done firstly in a manual mode, followed by verification with the software OpenText Magellan, and it allowed to establish and then confirm the tonality of a number of text containing words with this prefix. We can see that the vast majority of text are negative, and it should be noted that the use of software based on artificial intelligence technologies eliminates the need for manual word processing, expanding the capabilities of text analytics, combining a number of features provided by modern tools. Also, we can say that OpenText Magellan is good software that uses artificial intelligence technologies such as machine learning algorithm, conversion, and visualization of user research results, and it is provided free of charge and allows to increase operational efficiency. And other research results may also be useful in journalist practice, and as a result of complex analysis, it is revealed that in the language of online media, words with the prefix anti and without it are in antonymous relations, but in some contexts it can be in synonymous relations. There are some examples of such relations on this slide, and depending on the communicative purpose, the author may use neologisms with the prefix anti to give even the publication a stronger tone. The use of these neologisms can be effective not only to create a certain tone of the expression of the whole text, but also to achieve greater dynamism of the expression due to the reduction of the text. And journalists use neologism with this prefix in the headlines of online media publications, while in the text these new words are replaced by the broader descriptive phrases. For example, one of the publication is headlined like anti-coronavirus fund is fully distributed, and the same information in the text is today the fund for combating COVID-19 is fully distributed. So it confirms the ability of such words to accumulate expression and to evaluate and serve as a means of language economy. And in conclusion, it can be said that such neologisms have pronounced tonality, which is due to the textual environment, and they also can affect the overall tonality of the text. And machine analysis revealed that the connotations of the neologism with the prefix anti to the general tonality of the text were confirmed, and in others the tonality of the text was different from the connotations of the word used in this text with the prefix anti. This may be due to different factors, as meanings of other words used in the text disregard in machine analysis of the meanings of words in particular lexical environment, or even differences between machine and individualized author's intellectual analysis of the text. Also, the obtained results allow to predict the expressive load, the emotional background of the whole text, and the use of research results will also give a possibility you to choose the most appropriate word for accurate transmission of information and to achieve savings in language resources. Thank you for your attention.
Thank you so much for the presentation. Questions are welcome. Then I have a question. What is the perspective of your research? Would you like and choose some other prefixes apart from anti, or would you rather go deeper into the COVID topicality?
Like on this stage, we only use this prefix anti, and especially in online publications not about during the COVID-19 pandemic period, and like we used some articles that were presented in newspaper День and on the online resource Українська Правда. So maybe like in further researches we will investigate another prefixes, but at this time it was only about anti and its meanings.
Thank you so much.
Thank you.
Any other questions? Okay.
Thank you.
If not, then thank you so much for your presentation. Thus, the next presenters on our list, that is the team of different scholars, and I am among them. Right? So let me try and share my screen and my presentation while I am looking for it. Right? Okay, so do you happen to see the slide 1, 6th International Conference, or not yet?
We see not only one slide, but we see 4 slides of your presentation. Yeah.
A lot of it. Okay, then let me try and find this letter F. Okay. This one, 6th International Conference.
Nothing changed.
Nothing changed. Okay, then just give me a second.
I have a small question. If you, what the future using of your this task?
Thank you so much. So the future usage might be diverse, right? So suppose we have teachers orienting more on didactics for teaching within the classroom, right? So this might be the didactic material for teaching students and training them how to translate. Suppose we want to have some further scholarly analysis of the author's style, right? Then we might develop other platforms for the same writer, and on this basis find out the dominant stylistic features or the dominant image features. Or suppose we would be more interested just on this technical side, right, or program developing. So then we would be able to improve or advance the work-done programming language itself to add further windows for further analysis. Thank you.
Oh, thanks a lot of this answer.
Thank you. Okay, then let me, so to say, take advantage. Oh, that's not the case. Okay, no. This one. No. Okay, so we are actually moving on within this philological sphere of text usage, right? So one more project made within the same, the original and the translation, that is not the concordance, right, but the dictionary of neologisms. So that is just on the level of lexemes. So in here, I was working with the team of my colleagues, that is Ivan Bechta, Bogdana Buta, Maria Tkachevska, and Vasil Bialik. We come from different universities, but we are united by one scholarly idea. Thus, in here, we present digitally lexicographized neologisms of Douglas Coupland's novel Generation X software for bilingual electronic dictionary. So what we So what we were trying to do within this paper, that is to develop the algorithm of bilingual dictionary compiling. The original and translation of Douglas Coupland's work were analyzed in the relation to neologisms extraction. 90 items from the original novel were selected and contrasted with their translated versions. Next, their definitions and context within the sentences were singled out. Then the software for the dictionary was created. Afterwards, the dictionary was filled up in accordance with the prior accentuated fields. All mentioned embraces the novelty of the paper since it has not been performed before in terms of bilinguality. So that is always the situation with the philological domain, right? So we do have a lot of tools for operating the already existing text material. But when it comes to a specific problem, specific philological problem, we do lack resources, right? So the same comes here with the work of Douglas Coupland. This work of his is famous for the neologisms, right? So they used to be occasionalisms used only by the author, but eventually they developed into the everyday usage of very many people. And we do have the dictionary of neologisms of this specific writer in English. However, we do lack one platform, united platform, a collection of his neologisms as being translated. So that is each time when you come across the neologism in his original writing, you need to scroll all of that different dictionaries, all the available material, right, to come up with a translated version. And we have united them into one resource, right? Thus, the results of the paper may potentially lay the foundation for other elaborations of multilingual electronic dictionaries of different authors. And that is quite specific. We are talking about this small localized, so to say, lexicalization, not that much talking about the global scale corpus, suppose, right? So later on, the results of this localized, authorized, so to say, neologisms might be compared to the general usage, making use of the corpus available both in Ukrainian and English. That's what we did. That is, we first had to collect the glossary of that neologisms available from the original. Next, we clarified the equivalence in the Ukrainian translation. Later on, we worked out the definitions to all of the items found. For the comfort of our use, the list is organized alphabetically, and we also had to come up with a joint decision on what method of translation was used, right? Because neologisms from the lexicogrammatical point of view, right, are created in different ways. They might be used with created with the help of new prefixes, new suffixes, joined, shortened, and so on, right? And all of these methods of creation, call for different methods of translation. So that is actually what we did on this glossary collection stage. And so that is just the very initial stage for you to see what we were doing, right? Just collecting, then having the translation, having the context, the sentence within which it was used, then having the definition, what it means, right? Within the scope of the paper. And that was the next stage, that was dictionary compiling. Thus, to open a dictionary program, we use Notepad++ interpreter. We download the file and press run. We use the Python programming language because it is very comfortable, right, especially for the philologists. So that is actually the sample. And then each dictionary element consists of two objects, a key and a meaning. In our case, the key is the neologism itself. The meaning is the Ukrainian equivalent and explanation. For example, in here, we see the family in the search term, and then press find, and then we have the key and the meaning, and later on the definition and the specification of the method of translation. We need to specify that we used one component, two components, and more for the key, right? So we took the neologism as it was encoded by the original writer. Thus, the key identifies the dictionary elements, the meaning resembles the data that corresponds to the key data. That is, the translation and definition of the word "our family" is displayed. And that is actually means "our family." The direct translation would be "Повітряна сім'я", "Повітряна родина", and it is what is introduced in the translation. And what is meant by this, that is фальшиве відчуття близькості, що панує серед працівників офісу або якоїсь іншої меншої спільноти. It should be noted that the meanings of the keys are unique. There can be no two identical keys in the dictionary. Thus, we can check this in another example. Let us suppose enter meism, that is from me, right, the pronoun, and ism, it has to be stated that ism suffix has quite a negative or pejorative connotations within the English language, right? So as a result, we get the unique meaning of the word meism, that is translated as ya, right, my ego, ya, ism, which is universal, right? So that is намагання індивіда самотужки сформувати підігнану під себе релігію за відсутності традиційного релігійного виховання. So that is in a way, that is me in the center. But when we just have the translation, suppose ya-ism or me-ism, without this additional definition and explanation, so it might be quite confusing. That is, suppose you have the same text, Google Translate it, and you will get absolute nonsense from the point of view of meaning transition or meaning rendition. And to talk about the conclusion, thus, the writer, the original writer, finds resources for enriching the story's vocabulary within the language system through word formatting and semantic emergence of new lexemes and migration of vocabulary and phraseology from slang and professional jargon to stories vocabulary. High-level data structures together with dynamic semantics and dynamic linking make Python attractive for rapid software development as well as a means of combining existing components. Therefore, we have chosen it for dictionary software. Next steps will be taken for multilingual development of the dictionary. Thank you so much for listening, and questions are very much welcome. Okay, if not yet on this topic, then I will gladly share and briefly talk on another project, right? So that is already a bit different angle. That is already about looking into the so-called deep layer, deep semantic layer. What is meant by this or that message? We have taken the writer Sylvia Plath and the I felt narrative label of her novel, The Belger. I felt that is about the main heroine who is projected through the narrator, the writer, about how she felt. Right, in most cases, those were some depressing ideas, right? We do know that Sylvia Plath actually revolutionized the world of literature, the world of writing, right? And the joint team of Ivan Bechta, Maria Tkachevska, Vasyl Bialek, and Nataliia Hrytsiv, we decided somehow to take this literary literaryness, actually textness, and somehow tried to tag them the same for the comfort of the further analysis and usage. Right? So that is what is what is done. I'm sorry. The paper is conducted within the scope of digital humanity and illustrates the combination of computational translatology in connection to semantics. The study aims to investigate the rendition of I felt narrative label presented in Sylvia Plath's novel, The Belger. Methodology of the research relies on cognitive strategy, that is about the macro level, and concept analysis, that is about the micro level. Special notice is given to the major level of narrative analysis. Thus, in here, we talk about the structure, that is the text structure, and comprehension. That is how we understand this text. To establish whether I felt narrative label of alienation is preserved in the translated variant, we employ TAI standard instructions and HML markup language, which encompasses the novelty of the paper. The research illustrates practical application of Antoine Birman's analytic translation to Ukrainian translations and presents juxtaposition of the source text I felt narrative label with a translated variants, and on this basis we define the tendency of the translator. Preliminary findings can serve as a critical model for translation analysis for better understanding of how the analytic of translation may be co-opted in the study of author's style dominance, being preconditioned by author's cognitive strategy, especially first-person narrative, with the intention to be comprehended by source text reader, a translator, and a target text reader. Thus, it becomes obvious that the phenomenology of thinking and cognitive experiences gain utmost attention of current studies within neuroscience, psychology, philosophy, philology, narratology, literary studies, and digital humanities. Promising, though less presented, is translatological perspective. So that is the comprehensive study on how emotions are verbalized into a textual form and moreover re-expressed in the translation. So that is, I would call this the paradox of disciplines, because the cognitive orientational studies appeared within the development of digitalized tools. However, they somehow developed separately, right? The cognitive study of somehow grasping the ideas, how mind works, how we produce the language, right? Somehow developed separately from computational studies. Although those are the computational studies who desperately need this algorithm, right, to teach the artificial intelligence somehow to generate certain ideas and to predict certain utterances in advance. Thus, emotion, cognition, and literature have already gained noticeable attention, and it goes with no wonder, right? So that is actually the field of interest for most of researchers and literary studies scholars. In this respect, we have taken Sylvia Plath's narration, which presents a perfect example of the narrator's alienated consciousness encoded in a literary text, because her unit message represented by a sentence discloses the content of a mental act of alienating. When we talk about certain terminology, we have to specify that we do view certain phenomena from the philological perspective. Thus, within the communicational theory of narration, a unit message should be represented by a sentence, and this conception of language is the content of a mental act of judging, wishing. Relevant is the understanding that the narrator, in here we have Sylvia plus, communicates her unit message of alienation by or within a sentence, thus textual means are relevant for the analysis. Therefore, the unit in prose fiction is not the word, but the event. If misinterpreted in translation, the event of the novel trivializes the original. The methodological point of departure is the combination of both cognitive top-down and textual bottom-up comprehension process from the viewpoint of reader, translator, and a translation studies scholar. Thus, textual bottom-up comprehension process is well studied. This implies that we identify the original narrative label one by one and study its translation both separately and in the connection to the whole network of I felt narrative label significance. But then this in mind, we dedicated the second part of our study to what changes or what is mostly destructive within translation or translating process. We do so in line with Berman's approach to novel translation. Centrally concerned is a feature of I felt narrative label from the viewpoint of Berman's negative analytic of translation. Thus, before that, we prepared the material for analysis using tag application towards meaning unit tagging. So that was quite complicated in terms of human-machine interaction, because once again, meaning unit within this specific philological problem or subject matter is not just the lexeme. It is not the word collocation or combination, right? So it might vary from one word to the whole sentence. So that is where this text needed to be human processed. Thus, the tag guidance define an open standard that can normally be applied to any text and may satisfy any purpose. In this respect, in focus is meaning unit designating I felt alienation by devastation and emotional dislocation. So we use the standard sentence marking, tagging, meaning unit, MU with us, and having the sequence numbering. And next, we have the sample of a chosen textness segment mark up, right? Thus, we do so in parallel the original and then the translation. Okay, and a sample of a created corpus, that is what we have afterwards, the whole text is processed, right? So we have this text, I felt like a racehorse in a world without race tracks. So that is our meaning unit to be later on analyzed from translation studies point of view. What might be the translation challenges when we talk about the novel parameters, right? So genre and novel structure is of great importance. So the novel under analysis is rich in flashbacks of the main heroine as the Greenwood, which shows the period of her studying in college. These flashback fragments abound in the chosen variables. I felt alienation by a devastation and emotional dislocation. The algorithm of analyzing the rendition of alienated consciousness being verbalized by conflict in translation might be described as follows. We have the sender expresses the content of a mental act of alienation in a linguistic form. Here is that is I felt narrative label. The first addressee, that is a translator, perceives this linguistic form by reading and interpreting it, and eventually understands its meaning and the content of the addresser's mental act. A translator then becomes the readdresser, re-expresses the content of a mental act of alienation in a linguistic form. The second addressee, that is our final reader, perceives this linguistic form by reading and interpreting it, and eventually understands its meaning and the content of the addresser's mental act. If the algorithm is conducted ideally, then the textual communication succeeds and the final reader's horizon of expectations is satisfied, but that is a rare case. So findings and discussions. Now we have chosen a number of I felt variables. In here, we see Varna, right, beyond the number Varna. And then we have the explanation to it that is mirrored in the heroine Esther. Sylvia Plath exemplifies her feeling of being split between a fabricated public self and a truer and more elusive hidden self. This variable or this meaning unit depicts the situation when Esther learned she was not accepted into the writing program she applied for and was obliged to spend summertime with her mother in the outskirts. She feels suffocated and trapped within the social norms that disgust and exhaust her. Variable 1 is presented by the comparison of a person to a racehorse in a world without racetracks, meaning deprived of the possibility to fulfill its natural desires and triggers. It is intensified with a comparison to a champion college footballer suddenly confronted by Wall Street in a business suit. His days of glory shrunk to a little gold cup on his mantel with a date engraved on it like the date on a tombstone. So that is actually very long fragment depicting one meaning unit, meaning he had to adopt to societal demands and reality suddenly confronted by Wall Street and a business suit. While his inner energy got suppressed, his days of glory shrunk to a little gold cup on his mantel, symbolizing the death of his dreams and ambitions, with a date engraved on it like the date on a tombstone. Thus, having this example in front of our eyes, right, we come up to this commentary on this specific example. So the variable is meant to depict an alienated individual who feels at a loss because of being relocated from the usual cognitive environment and placed within the realm of strange circumstances. The circumstances that intrude into self-well-being, which bother and do not feel comfortable or satisfying anymore. The location itself may rename unchanged. In variable 1, the main heroine communicates her current state by illustrating discomfort compared to a racehorse or football player feeling perplexed and aghast when put in the order conditions. So that is actually for this translation reflection, right? We do all of that prior stages of text markup, deciding on a meaning unit related to I feel or I felt variable. And having done all of that throughout the text, we have a clear holistic picture. Thus, we may come to certain philological conclusions. Right, so the study explores how I felt narrative label of Sylvia Plath is translated into Ukrainian. Necessary to know that the current analysis does not exceed the realm of this specific narrative label and should not be considered evaluative in relation to the whole translation product. In a lucid way, we try to discuss and compare I felt narrative label of the original and translation, analyze how it is translated into Ukrainian by Olga, access the translated products on the basis of Antoine Birman's analytic translation, negative and positive, and the perspective of this study might be conducting this kind of analysis on the basis of other texts, be it multilingual or monolingual. Thank you so much for your attention. Questions, if any, are welcome. If not, then I would kindly invite Nataliia and Viktor Sorokin to present the topic on parameterization of the Ukrainian text corpus based on parsing results. They present Levchenko National University of Kyiv. So do we have Nataliia Darchuk and Viktor Sorokin? You're welcome.
Hello. I will present our work today. Parameterization of Ukrainian text corpus based on parsing results. Our aim was to describe the principles of syntactic parsing of Ukrainian language text based on dependency graphs, as well as showcase text parameterization based on Lina Kostenko's poetry, as shown in the Ukrainian text corpus on the MoInfo portal. The tasks we worked on during this project include linguistic analysis of Lina Kostenko's text, creation of database with linguistic units present in the text with their grammatical and quantitative features, development of a user interface to easily search, sort, and perform statistical analysis of the database information according to the search goals. The individual style of Lina Kostenko's works is the object of our research, as it requires a deep and multi-level scientific analysis. The syntactic structure of the sentences of her poetry is the subject of our research. To illustrate the methodology used, Lina Kostenko's ballad poem Scythian Odyssey was chosen as an example. We analyzed almost 1,000 sentences, which contain more than 8,000 words. Lina Kostenko's individual style requires detailed, balanced, in-depth studies. The corpus information system of Lina Kostenko's text we created provides a lot of information about the parameters of the author's language, and this system convenient to use in various studies, including text creation. This underlines the scientific novelty and theoretical and practical value of our work. The parsing itself aims to detect all relation types between words in the phrase, predicative, coordinative, subordinate. It is well known that lexical and grammatical features of the word determine its compatibility with other words. Therefore, different types of word phrases need to be detected during parsing, as different parts of speech can be its head, non-adjective, non-numerical verb and adverb. The one-instance subgrammars that contain information about the lexeme, the governing position, and the grammatical case of the governed complement were used during the analysis. The following types of semantic syntactic relations were automatically established between phrase constituents. It's subjective relations formed between the subject and the predicate that constitute the nucleus and the sentence. Objective relations in which the direct and indirect object is dependent. Attributive relations in which the adjectival dependent modifies the head word. Adverbial relations in which the adverbial dependent modifies the verb. Completive relations between the components and complex constituents. Appositive relations between the positive and head word it relates to. Here you see a sentence from Lina Kostenko's poem, Scythian Odyssey, and the dependency table automatically created by the program. Morphological annotation is provided for the sentence. The table contains head words of the phrases, their dependence, and the syntactic relations between them. This allows creating alphabetically ordered frequency dictionaries of phrases based on relevant works of a specific author. This slide demonstrates a graphical representation of a dependency tree created automatically by automatically inverting the dependency table. The dependency tree consists of nodes and edges, where nodes represent the words and edges illustrate the relations between head words and dependents of a phrase. Aside from that, additional information on types of relations between nodes is given. This makes it possible to describe the configuration, form, and outer parameters of the sentence. However, this is not enough to present the structure of the sentence. The information about the type of relations between the constituents of the phrase and syntactic relations is automatically applied to the set of three edges. This helps with analyzing complex correlations between semantics and its formal representation, as the text is parsed automatically based on the formal features of its units. Automatic syntactic analysis of the sentence is done on two levels. For each phrase, the program determines its syntactic type based on the morphological features of its head, and syntactic relation type is determined for each edge of the graph. The research shows that let's say smooth and rhythmic flow is not characteristic for the ballad poem Keep Henadii Same, as it's full of complex sentences with asymmetrical clause structures. Simple phrases often frame a complex sentence, while their dependents are situated in the middle of the sentence. The use of ellipses is also an important feature. Long right-oriented paths with consecutive simple clauses of the same length are also important for the author's individual style. The poetry includes both simple and complex sentences. Even short sentences of Lena Kostenko are diverse. Sometimes symmetrical microstructures appear, and there are maybe solely right-oriented trees starting with the predicate. In non-projective sentences, the edges cross because of peculiar word order, which is not usual for Ukrainian. Further research prospects involve collecting more statistical information based on the corpus of Lena Kostenko works. Computing the frequencies of simple, complex, compound sentences, elliptical sentences, interrogative and imperative sentences of all word phrases, types, etc. This will allow us to determine the diagnostic power of the different parameters. A table with information about all the parameters should be compiled, paying attention to statistical features, data classification, and various deviations. This table will make it possible to compare text of different authors or text of the same author. In addition, specific functions of parameters could be seen, as some parameters show the similarity between text, while others highlight the differences in language. Based on the parameterization of the whole corpus of Lena Kostenko's works, an average graph of her sentence could be created, which could be interpreted as a constant feature of the author's individual style. The novel software we created adds more features to the Ukrainian text corpus and makes conducting linguistic research more convenient. Thank you for attention. Questions?
Thank you so much. Dear participants, questions are in order. You're welcome.
May I take a question?
Of course, you're welcome.
What I will obtain by these parameters of each tree? I have many trees, many parameters. You listed all of this, and how to compare, how I can use it.
Right now, it's as I mentioned, it's our perspective direction that we plan to investigate the possibility to derive from these values some, let's say, footprint or fingerprint of the individual author style. So let's say each author will be different, that they have different average number of nodes in the tree, or different other parameters. It will help to identify differences or commonalities between different authors when we will summarize or aggregate this data. This we need to make more investigations, maybe more help for mathematical specialists to identify paths in this.
Then this tree is made automatically or manually, such every sentence tree and estimation these parameters.
All these parameters, all these trees made automatically, but some of trees, of course, system not super smart to make them full. So some sentences were reviewed and updated manually. So at this point, automatic algorithm can recognize like maybe 70–80% of the text, and sometimes it creates wrong connections between nodes. So this need to be updated manually after a system automatically processes the text.
Okay, thank you.
Any other questions? I do have one question concerning the situation. So very often we have the theory and then we come up to the practice, right? To somehow prove the theory. So did you maybe manage to notice on your practical application that some new hypothesis would pop out, some new theorization would be possible on the basis of the practical analysis that you have conducted so far?
Sorry, connection is bad. I see here only parts of.
Let me repeat, and if that fails, then do not answer. So very often we first have the theory, and then we move to practical analysis to support the theory, right? And my question is, maybe you managed to notice that that was something new based on your practical analysis that would later on allow you to come up with some new hypotheses or some new theoretical ideas, judging on the analysis that you have already conducted.
Yeah, the idea of, let's say, deriving new ways to investigate was behind the option that we can process automatically a lot of text and see if some parameters can be informative for, let's say, distinguishing author style between one another, or to make other conclusions. Before our research, before we managed to implement automatical syntaxis analysis, it was really hard to see what metrics of the sentence can be even calculated or be different or the same for different authors, and having all these matrices like this one, like here or another, only after calculating them and starting to compare, we can see what other directions in our research can be found.
Thank you so much. Any other questions to the presenter? If not, let us kindly invite our next presenter, that is Alla Taran from Cherkasy Bogdan Khmelnytsky National University, and the topic is the role of keyword language in the database of World Slavic Linguistics, ICBSLAV. I do not see the participant so far among the presenters. Okay, she might join us a little later on. Then we would kindly invite the next topic to be presented, that is correlation analysis for text author identification, results based on n-grams frequency distribution in Ukrainian scientific technical articles. The team of presenters is Victoria Vysotska, Oksana Markiv, Sofia Tesla, Eva Romanova, and Inessa Pigulechko, presenting with Polytechnic National University. So you're welcome. The floor is yours.
Good afternoon to everybody. Welcome to our presentation. My name is Oksana Markiv. I'm PhD in Structural, Applied and Mathematical Linguistics, Department of Information Systems and Networks. Today, I'd like to present to you our research work, scientific work, correlation analysis of text author identification results based on n-grams frequency distribution in Ukrainian scientific and technical articles. Going to be focused on such aspects depicted on this slide as experimental approbation concerning author style, identification in Ukrainian scientific and technical tests, text quantitative content analysis of the scientific and technical texts based on content monitoring, some kind of web mining, stellometry methods determining the author on the basis of such speech coefficients analysis as lexical diversity, degree measure of syntactic complexity, speech coherence, indices of text exclusivity and concentration, and also some parameters of the author style in order to make a stellometry, such as the text words, sentences, prepositions, conjunction quantities, and the number of words with different frequencies. In our work, for such investigation, were possible to use such methods of investigation concerning mathematical statistics, concerning some methods of author identification, the means of text analysis, methods of text authorship based on calculation of any text characteristics, also information entropy, Fisher information, and some apparatus for linguometry. Due to the increasing distribution of electronic documents, it is obvious that there is importance to use automatic methods to analyze the content, text content, in the internet, because open web resources are very popular today, and the task includes the necessity to classify documents by various criteria. And the main problem is to distinguish such criteria, to take into consideration all parameters, genre, writing, formal, speech style. Yes, the concept of author identification is defined in our work as the process of such determination, identification based on a set of features that constitute author style. And this slide shows this identification based on the text author based on DFD. This slide demonstrates what is DFD. Yes, in our work, it's a distribution function density. This slide demonstrates identification based on distribution function density. So to compare the text with each other, it is necessary to compare the text with some numerical characteristics that very close to the text of the same author and will differ from others. So it is obvious that one author has different and various characteristics than another. Yes, numerical and other. Such characteristics use the DFD of letter combinations of 3 consecutive characters. It's, as you know, 3 grams. Yes, so our work is based on investigation of n-grams, basically on 3 grams. Here there is written what main conclusion about linguometry, what was used, yes, in our work, for what reasons linguometry is used. Yeah, it's a branch of applied linguistics that detects, measures, and analyzes the quantitative characteristic of different levels, units, language, speech, and we decided to take such branch into consideration. So the next slides will show some results of our correlation analysis based on n-grams. And 1 minute. Yes, a result of letters correlation frequencies of the passages. Yes, here you can see that it is possible to evaluate the speech of author on particular passage of his work using the example, not example, but reference text taking into consideration Ukrainian language letters frequency. So this is obvious that there is passage number 1, passage number 2, yes, and this relative and absolute frequencies of letters correlation in the text and in different passages. Graphical demonstration of results is shown on this slide. It gives a convincing answer to the question which passage was written by which author. So this graph was made in order to understand relative frequencies of letters in the standard and studied passages. Yes, here there is letters and here there is frequencies. Also relative frequencies of occurrence of 10 most frequent symbols in standard. Because we have realized, maybe investigate, yes, that these letters, which are here in the figure number 3, are the most frequent, yes, and relative frequencies of occurrence of 10 most frequent standard 2 in passages number 2. Peculiarities of reference text analysis are demonstrated by this slide. For high quality and effective analysis of content in determining the degree of authorship of a particular person, we propose to analyze the reference text in several stages. So in order to analyze good, we should have some template, maybe, yes, and we pretend to maybe to share with this template with these stages. Yes, it's reference text and other stages are here on the left side. It's a linguometric analysis that I was spoken previously, stylometric analysis taking into consideration the style, analysis of stable phrases, because speaking about n-grams, we understand that from a practical point of view, maybe it can be some syllabus in theory, in semantic, from semantic point of view. Yes, it can be some syllabus, some letters, separate letters, some maybe other parts of speech. Yes, but from practical point of view, this is stable phrases. Yes, something words, maybe words combination, stable words combination. A linguistic statistical analysis through n-grams, web resources for linguometric analysis. And here there is algorithm number 1, linguometric analysis of the text to determine authorship. So you can be acquainted with it on the slide number 7. And the next slide give us examples. It's some in the article, there are a lot of such screens, figures, yes, but we try to share with you maybe with some screens that from our point of view are the most important maybe in our work. Yes, it's linguometry, it's a determination of numerical characteristics of speech. Here you can be acquainted with it, linguistic analysis application result. And here there is a slide which demonstrates peculiarities of correlation analysis, example of voice speech coefficients calculations. There is such coefficients as lexical diversity, speech connectivity, syntactic complexity, concentration index, exclusivity index. Yes, and in common data and our calculation, and also this algorithm number second, yes, telemetric analysis of the text to determine authorship. It consists of 16 steps, different steps, yes. So I think I shouldn't read it, but you can be acquainted with it. And previously it was a screening of linguometry, and here there is a screen of stilometry, example of data entry for stilometric analysis in order to analyze the style of different author. So the main maybe object is to study this style concerning different numerical and other characteristics in order to prove that even if we don't know author, we can maybe figure out who is it, even not reading the whole paper, and even not reading maybe who was writing it. Yes. There is also some screens of example of stilometric analysis application results. There is a graphical representation, table with coefficients of correlation. As it was said before, in order to compare the text with with other text, it's needed to compare some numerical, to compare this text with some numerical characteristics based on n-grams. So as I have said previously, n-gram is a sequence of n elements. From semantic point of view, it can be sounds, words, syllables, letters, but in practice, these are stable phrases, collocations. So it's more simple to make such analysis if speak about n-grams like collocations and stable phrases. And this slide demonstrates us algorithm number 3, linguistic and statistical analysis of n-gram of text. Is the following. Yes, what should we do? Purify, study text, because we know that in the text there are a lot of noises, a lot of maybe unnecessary information that can be like a background, which can be unnecessary, not in order just to make it bigger. Yes, so it is possible, it is needed to purify the study text, to clear it, yes, to number special symbols, to calculate the number of words in the text. Also, we translate in lowercase, no spaces, yes, in order to make this analysis. Because in order to make some program work, we should have some reference text with this text we can work, yes. So, and in the result, we can export CSV file, yes, store it on the server. The results of the study are displayed on the screen, yes, and so 1 minute. And so in our work, we have investigated 3 articles, different articles by different parameters. Total characters in plain text, in the raw text, total words, total n-grams found with, here you can see it on figure number 8, yes. And there is some figures, some numbers that was investigated in the result and obtained. And this use of 3 n-grams starting with the letter A are shown on this slide. And distribution of frequencies based on 1 gram, 1 gram to 2 gram, yes, and 3 gram. According to table 4, applicative letters in the Ukrainian language are most often used, others much less often. For the most frequently used letters, the frequency occurrence of 3 grams with such initial letters will have almost the same distribution. So main subject is that there are those letters that are more used and those that are less used. Frequencies of studied passages are shown on this slide. figures show that low frequency values noises, yes, something that's necessary, we should get purified, are the most common and forms the main volume of data. So conclusion of this slide is that 3 grams are caused by stylistics of grammar and are not relevant to determination of the topic of author, article, but it's crucial to determination of author's style, yes. And relative frequencies of 3 gram consumption has been smoothed by such methods, because if we have noises, we should omit these noises. In order to omit it, we decided to use such methods as moving average method, exponential smoothing, and median smoothing. Here there is some examples of these methods, not all, because there are a lot, and we decided to add just one for each method in order to understand what it is. So you see that information is smoothed, yes, make better for understanding. Graphical representation of the relationship between 2 study sequences is called a correlation. It's known, but from our point of view, it's some kind of field scatter plot. The graphical method provides a visual representation of the form of communication between these sequences, and this slide demonstrates graphical representation of autocorrelation that used to find patterns in number of data, such as periodicity. And it's known that graph of autocorrelation functions also called like choreogram, and here are 3 examples of this choreogram. So first, experimental research, our experimental research needed to test the proposed method to determine the style of the author from other categories, scientific, humanities, art, journalism, and to make some new experimental result in order to understand if this method is really workable in every environment, yes, in different styles. The application of linguistic and statistical analysis of 3 grams to a set of articles will allow to form a subset of similar linguistically characteristic publications, because if you analyze something according to some rules, we can speak about some programs that can be maybe used by everyone in order to have some good results and to understand how it works. Yes. So conclusions, what was done? Population analysis of text author identification results based on n-grams in Ukrainian technical and scientific text. Quantity content analysis of textual, scientific, and technical content. We have proposed methods of determining the author by decomposition on the basis of analysis of such speech coefficients and lexical diversity, degree, syntactic complexity, and others. Also, relative frequency of 3 grams consumptions. Such kind of smoothing was proposed. And it is suggested to analyze the referent text in their several stages, the slide was shown. And highlighted the importance of numerical characteristics, as it was close to the text of the same author, would different in the works of various authors that uses the distribution function density of letter combinations of 3 consecutive characters. And such rapid distribution in electronic form has caused the importance of using automatic methods to analyze the content, including the necessity of documents classification. And that's why this theme is topical for us, because open web resources are very popular, electronic form are very popular, and we should know how to analyze this text by a different point of view. So thank you for attention, and wait for your questions if you have some questions. I'm glad to answer them.
Thank you so much for your presentation. Questions are welcome. Oksana, so you have mentioned that you are a PhD student, if I'm not mistaken. So is this the part of your research?
No, it's not part of my research. I'm PhD in computer structural, applied, and mathematical linguistics, and my part of work was tourism documentation, and I was working with it, and I'm PhD in it. But now it's too close for my research. Yes, it's not my investigation for thesis. I understand what do you say? What do you ask? Yes, if it is my thesis. No, it's not my thesis, but it's work relating to this field that is very close to me, and this field that is understandable. Yes, it's some kind of correlation between computer sciences and linguistics. You understand? Yes.
Thank you so much. Any other questions? Once again, I am reminding you, in case you feel like catching up with the questions, so feel free to use our chat box to address your questions to a specific.
You know, something is bad with connection, and I don't hear you good. Maybe can repeat, or maybe I stop sharing, or because I don't hear.
Okay.
Something is glitching.
So let us invite our next presenters, Solomia Kubinska, Roman Holoshchuk, Svetlana Holoshchuk, and Lubomir Chirona, who would like to present on the topic Ukrainian language chat box for sentiment analysis and user interests recognition based on data mining. So that is Solomia Kubinska, Roman Holoshchuk, Svetlana Holoshchuk, and Lubomir Chirona.
I'm afraid it was moved to another section.
But that is someone joining. I mean, Solomia or Enoch, maybe that is the presenter. Okay, then we kindly invite Viktor Shenkarenko and Inna Demidovich to present the topic natural language texts authorship establishing based on the sentences structure. They are presenting Ukrainian State University of Science and Technologies. So do we have Viktor Shenkarenko and Inna Demidovich?
Yes.
You're welcome.
Yes.
You're welcome.
Thank you very much. I'm running my presentation and I will start. So, dear colleagues, first of all, I want to introduce myself. My name is Inna Demidovich, and I'm a PhD student of Ukrainian State University of Science and Technologies. And Viktor Shenkarenko is my scientific supervisor. We want today to present you our work, which is dedicated to natural language text authorship establishing based on the sentences structure. The main idea of this work is that each author has its own style of building sentences. So we try to find out the way author builds their sentences, catch it, and use it later in authorship determination. In our work, we use two methods. First method is stochastic grammar. We use it to create rules that describe the structure of sentences in a text. And second method that we use here is students t-test to count confidence interval for all authors that we have in our samples. So how do we form our rules? First of all, each word in a text is replaced with the part of speech to which it belongs. After that, we count the probability of its occurrence in some specific place in sentence. And after that, we can say that each rule shows the transition from one word to the next one and its probability. To build the rule, all sentences starting with the same part of speech are grouped for calculating its probability. Then the first word is discarded and the procedure is repeated for the next word. Probability is calculated as the number of cases in text divided by their total number. Now on your screen, you can see example of few first sections of a rule that represent sentences in the text Etude by Ivan Bagriani. And according to these rules, you can see that 31% of sentences in this text begin with a verb, and even 17% of the sentences consisting only of one word, which is a verb. How we compare two works. First of all, to compare works, we need to present them in a form of the rules. After that, each sequence of rule in one text is compared with each sequence of rules in the second text. The degree of similarity of two sentences is determined as the product of the minimum differences between the probabilities for their applying. And the degree of two text statistical structural similarity is the sum of all its sentences similarity degrees. Also, to obtain more reliable result, we calculated confidence interval for each of the authors in the samples. To do this, we apply students' t-test. And now about our training and control samples. The whole experiment we can divide to two pieces. In first part, we have 20 works of literary text by 10 Ukrainian authors that were selected to the training samples. The name of these authors you can see now on your screen. And the control sample consists of 3 works by each author. And in the second experiment, we doubled all samples, training and control. Here in this table, confidence interval by authors are presented. We can say that confidence interval can also be a characteristic feature of author's personal style, because if author has large confidence interval, it may indicate a low level of differentiation of the author's style, and as a result, we have bad results when we try to determine authorship of his texts. And vice versa, if author confidence interval is small, that means that we have strong author style and his works are easily determined. And now I want to present you result. Here you can see the figures that represent our result working with the smaller of two samples. According to that, we have 25 cases of correct authorship attribution, and it's 80%. We can say that such authors as Levchenko, Myrny, Nestaiko, and Podmogilny have strong author style, and we get good results working with them. All works that we use in our control sample where their authorship were established correctly. And unfortunately, working with Ivan Franko, we can say that his author style is the most difficult to define. And next figure represents results that we get working with the bigger sample, with double samples, yes. And here we have correctly determined cases in amount of 45, that is 75%. The best result we get working with the text of Panas Myrny, and the worst result we get working with Kvitka Osnovyanenko and Markovov-Chok. After that, we taken into account the confidence interval of the author and get next result. In 14 cases, one correctly recognized candidate was obtained, and it's 23%. In 36 cases, the program was able to narrow the numbers of applicants to 3. Within them, 31 cases, the applicant with the greatest structure similarity was the correct recognized author, that is 52%. And only in 10 cases, the authorship of the text wasn't determined, that is 16%. So we can say that the range of the result that we get begins from 75 and reach 80% without taking into account the confidence interval. And after we count them and use it, we improved our result and reach 83%. Also, we can say that confidence interval is a characteristic feature of the author's personal style. What we will do in future, first of all, we want to combine this method with previously studied methods. And also we want to do more detailed tagging of the sentences part, such as not only part of speech, but also different forms, numbers, gender, etc. This will get more information about the sentences structure, and we hope it will get us better result of authorship determination. Thank you for your attention. Do you have any questions?
Thank you for your presentation. Any questions, please? Thank you so much. Then let us move to our next presentation. The presenters are Andrei Kopp and Dmitry Orlovsky, talking on the topic an approach and a software tool for automatic source code generation driven by business rules, presenting National Technical University Kharkiv Polytechnic Institute. You're welcome.
Thank you, and good day, dear colleagues. I'm glad to present our paper by me and my colleague, Dmitry Orlovsky. We propose here an approach and a software tool for automatic source code generation driven by business rules. And the motivation behind our study is the fact that source code generation can really increase the software development process and shorten the time between requirements gathering and the software delivery using automatic programming and low-code solutions. In general, the idea of low-code programming is that we need to only tell the computer what to do rather than how to do the task. And this is why the automatic programming must be supported by some high-level languages that are closer to natural languages than some programming languages. And this paper aims at automatic source code generation from natural language statements given as business rules to improve the software development process, to shorten its time, and bridge the gap between business analysis and engineering activities. In this study, we use the SBVR, which stands for Semantic of Business Vocabulary and Rules standard, to provide unified solution that can be maybe in future integrated with other software development utilities and environments. In this study, which continues our previous one, we want to use the model-driven development approach, in which business rules are given as subject domain descriptions that help to build an abstract model of some domain, which may in future have several possible technical implementations, like in different languages using different technological stacks and so on. So the first step in our approach is the translation of business rules into the triple store model. Our procedure, we propose to do this translation, allows to tokenize each business rule, mark each token, each word as the part of speech, and then process these parts of speech to produce the set of triples. And this set of triples we obtained are represented as subjects, predicates, and objects, and we can actually use them to retrieve the full set of triples or to retrieve some subsets of triples to build then object-oriented entity relationship or other models. After we obtain such triple set, we need to translate it into the data model. And first of all, we decided to restrict the syntax of business rules. We proposed to consider only several verbs according to their purpose, like has, which will mean that unnecessary attributes are described, and these attributes can hold null or missing values. Owns, which means that this attribute is mandatory and it cannot hold null or missing value. And includes this verb describes the direct relationship between two entities. Like here, we have descriptions with owns for the necessary, for the obligatory attribute title for the product entity, and has as for the description attribute, which is not necessary attribute. And if we give another rule, product includes category here, it will describe the following relationship as one-to-many between the category instance and possible multiple product instances. So having such data model also built using the proposed special procedure, we can build then different software implementations of such abstract model, like SQL database creation scripts in for the relational database management systems, or some programming language classes or structures, like, for example, Java beans, or maybe enterprise Java beans, or other software artifacts. And the next step, after we can extract from business rules entities and attributes and relationships, this step requires to suggestion of data types for the attributes. Only by using the names of these attributes, and to solve this problem, we used the spider data set. It's a data set freely available. It's created by Yale students and some employees. It includes about 200 SQL databases with multiple tables, of course, that cover 138 different domains. And we use the association rules approach to find out the most suitable data type for any attribute presented in this data set. And like here, for example, for phone, we have found the highest weight is the data type varchar with the length of 24 characters. And this approach can be used to identify other data types for the attributes given in our abstract data model only by their names. Or by default, we suggest to use the text data type for attributes which names are not presented in such data sets, so they cannot be identified by the association rules approach. And finally, we had to adjust these suggested data types because in those spider data set, it uses SQL language and SQL specific data types, but we can use the special procedure and the mapping between languages, between the most popular technologies for enterprise software development to suggest specific data types, like for Java, for C#, for SQL, or for Solidity language, according to the generic data type we have identified. So first of all, we proceed the data types suggested from the spider data set, and we categorized them into 4 groups: integer, floating point, Boolean, and string. And according to the selected technology for which we may produce the software code, we may suggest the specific adjusted data type. Of course, such mapping is not final. It can be extended in future, but we used this mapping to conduct experiments. And finally, the general idea of this approach is to build an abstract data model from business rules to define entities and attributes and relationships between these entities. And the data model based on business rules can be used to automatically generate almost any software components with only using rules that describe syntax of entities, syntax of attributes in certain programming language, or any other data objects, data structures, description language. Also syntax for the relationships definition, and the rules how data types can be translated into specific syntax of selected technology. So we have created a software prototype based on the proposed approach. It was created using the Python programming language because it's relatively simple and flexible, and also rich of packages, and of course for the natural language processing packages like NLTK we used, and the packages for databases operations. We have demonstrated an example of source code generation from business rules. This simple set of SBVR business rules describe a subject domain of some imaginary e-commerce system, which includes products, categories, and brands, entities, and also their respective attributes. So on the first step of our approach, we obtained the triple store model based on these business rules. We then used all of this graph of concepts and interconnections to obtain the data model. And this finally, this abstract data model then was appended with the suggested data types based on association rules approach on the as a result of spider dataset processing. We only didn't get any suggestion for the image attribute with the name image because unfortunately it's the drawback of association rules approach. Those spider dataset didn't have this attribute in any of its databases. But using the other data type suggestions and abstract data model in total, we obtained two types of software artifacts: the SQL code for database creation based on those data model, and Java beans. Java beans are like plain old Java classes with default constructors, so they are used to provide some mapping to relational database tables in Java enterprise development. So we have also performed the static analysis of Java beans code generated using our software. Unfortunately, it demonstrated several issues like incorrect formatting for class names, for field names and method names, and also usage of generic exceptions instead of specific ones. But so it was successfully compiled into classes. However, the remaining refactoring can be done by the user of such software tool according to some code conventions accepted by a certain team. And we also executed generated SQL database development scripts. They have also demonstrated successfully created tables in MySQL server. And we also checked data integrity and data consistency by trying to test foreign key constraints to add not existing, to add child row which references to not existing parent record. Of course, our structure demonstrated fail for such illegal operation. And we also tested constraints of null columns. It was also successfully demonstrated that for the business rules that declare mandatory columns were successfully, mandatory attributes were successfully translated into the not null columns. And so finally, I already discussed the limitations, but this approach may contribute to the intelligent source code generation systems, and it may breach the gap between software requirements gathering and design of information systems data layer. And in future, this software tool and approach, after certain improvements and development, may result in automatic source code generation environment or tool that can be a standalone or can extend traditional integrated development environments. So thank you very much for your attention.
Thank you so much for your presentation. Questions are welcome.
Can I ask a question?
Sure.
Of course.
It's very interesting work, but how looks like this business rules? Should be interesting to understand.
Yeah, these business rules are given as these short descriptions. according to the SBVR standard of simple English business rules.
Yeah, okay. Then user can write some such business rules and enter set of rules and obtain data definition language software and create database, yes?
Yes, and from these business rules, users can get a code to create a database and a code to create Java for now. For now, we tested on Java code generation for the software development for the database. In addition, as some data layer.
Mainly for relational database.
Yes, for now it's for relational database.
Okay, but when a user do something wrong, not good, not ideal rules, what happens?
As far as we experimented, the incorrect business rules, they are only ignored by the software and by the approach in general. But maybe we will also think on how to suggest for users how to fix their typos or how to show them their mistakes. That will be also interesting.
Okay, thank you.
Thank you very much for the question.
Very interesting.
Thank you.
Any other questions? I do have one practical question. So how many hours, how much time does the development of such a product take? So that is when we talk about one person, a team, right? So how long do you do your research?
You mean how much time it can help to save, or how long?
No. How much time you as developers dedicated to this project?
Maybe a couple months.
So that is
yeah, but it's a really raw product. It's like a prototype. It's not suitable for the maybe real usage now, but as the prototype, maybe it can show some promising results in future.
Thank you so much.
Thank you.
Do we have some more questions? Then let us turn our sights to our next team of presenters. That is Nataliia Borisova, Karina Melnik, Nadia Babkova, Victoria Melnik, and Zoya Kuchuyeva, talking about gender classification of surnames, Ukrainian aspect. They present National Technical University, Kharkiv Polytechnic Institute. So you're welcome.
Okay, hello everyone. Do you see my screen?
Yes.
Okay. My name is Nadia Babkova, and I would like to consider today the topic about gender classification of surnames, Ukrainian aspect. My college and I are going to share with you some of important ideas that we have discovered in this area. Nowadays, we can see the actualization of research in the study of gender aspect in language. So to begin, let's first set some definition. Like definition, we have gender linguistic is the scientific field of interdisciplinary gender research that studies gender in its linguistic manifestation with the help of the linguistic conceptual apparatus. And grammatical gender is the way of classifying noun and collocation that in predicable assign then gender categories that are often not related to their real world qualities. The practice of using names in different countries is different, so it's necessary to use database of names of a certain language that already indicate gender. This study proposed an approach to solution of the problem of determining gender for some author of the general regionally annotated corpus of Ukrainian. So Grek is the Ukrainian language corpus with a volume of more than 650 million tokens. Consider the wording of the gender determination task of Ukrainian surnames of the author and their text. This task is classification task in general term. So the object of classification is a set of Ukrainian surnames of the author of the Grek corpus with unknown gender. Input data is the various characteristic and indicator of the text and surnames. The result of the gender determination task is two classes. It's male and female. Therefore, the gender classification task is mapping on one set of another, and in this SI can be divided to the following tasks that you could see on this slide. Because we talk about natural language, so there are many general accepted methods of processing the natural language in linguistic. Each method has its own advantage, disadvantage, limitation, and capable of providing information, of paying completeness and a share. The condition analytical review of mathematical models and the futures in the subject area allow making conclusion that a Bayesian classifier can be used for gender classification of surname and their text. So we decide to use here Bayer classification, and let's consider the process of solving the problem of gender classification of surname in more detailed way. The gender classification process consists of two stages. The first one released the implementation of gender classification of surnames with clear gender characters. The model of this business process is present of the form in the form of BPMN diagram here. The process starts from the forming of a training data set with female and male surnames. There are many suitable ending of female surnames like Ska, Skaya, Ova, In, and other. The ending of male surnames are the following: If, Kov, Sky, Nov, and other. Then the train classifier carry out gender classification of new surnames. The findings are recorded in two files according to female and male surnames, and next step is checking the result by an expert. The efficiency of the classifier is evaluated according to the actuary metrics. The obtained results are used into the next stage. And on this slide, you could see the next the diagram about next stage. So the second stage shows the process of surnames classification without clearly accessed gender futures according the author's text. Input data is a file with mistaken defining surnames from the first stage and set of surnames which don't have clear gender characters. There are many such surnames like Shevchenko, Potebnya, Tychina, Plaksy, Melnik, Movchan, and other. To use the classifier, it's necessary to form training corpus of text from Grek according to the available futures. One subcorpus with text written by women and another by men. The set of texts have been formed based on the subset of well-defined surnames from the first stage. More the time of writing to the text should be taken into account. To define gender identity of author of some period, it's necessary to use a base of text with such period period of writing. Usage of text from another time period leads to unreliable classification results, and the linguistic characteristic of this text significantly depend on the writing period. So then the training corpus is created. The classifier is training and used for new unknown text. And analyzed text is divided into sentence where many marks of the end of sentence, a period, an exclamation mark, a question mark, new line and tab and other. The classifier conducts the following action for each sentence, calculating the number of punctuation marks, dividing the sentence into words, lemmatization and morphology analysis, calculation of the number of different parts of speech, counting the number of idiom and phraseology, counting the number of words with the roar and other. The obtained information is the base for the calculating of the classification identifier is the whole text. We have many informative task or mark from text. So the most important stage in the resolving of the classification task in the forming of the input data, the analytical review of the different literature sources about gender futures of the text world determine the set of informative text characteristics. And here you could see the part of processed identifier which we can use for the gender classification on the text. Okay. This research proposed to use naive Bayesian classifier as a classification method. Both stage of gender classification task use classifier. The first step of mathematical model for solving the key problem is the forming of input data. Input data for the first classification task is gender futures of surnames. Input data for the second classification task is futures of the text. The training and using the classifier for the both tasks of similar for each other. Consider the process of use the naive Bayesian classifier on the example of resolving the text classification task in more detailed way. The algorithm consists of two stages. The first stage is responsible for training of Bayes classifier, and the second one describes the process of using the Bayesian classifier, which has been trained during the previous step. The naive Bayesian classifier is probabilistic classifier that use the Bayes theorem of determinate the probability of belonging to this simple element of one of the classes assignment the independent of the variable. So the Bayes classifier can be applied to any data set that can be represented of categorical data or list of future. It's often very effective than working with the data despite assumption about the independence of the future. Another important features of the such classifier is that it can be built in a new simple with missing value. A former research has proposed to use different metric for estimating the efficiency of the developed classifier. It depends on the problem being solved. The accuracy metric has been chosen for efficiently estimation of the task of classification of surname with gender futures. The precision and recall metric were chosen for efficient estimation of the task of classifier of surnames without gender future. The calculate values of chosen metric for pre-research and present in table of this in first table of this slide. The classifier used the data set for the first stage, which contains 500 male and 500 female surnames. The structure of training set and result of using the set of following. So 1,000 and 1,000 more than 1,000 surnames from the training dataset were identified as male, and we have good result for our metric to choose to correct choosing of male and female surnames with the endings. So for the second stage, classifier was trained on subcorpus consistent in the text writing by 13 males author and 30 males author and 30 females author. And we use in the second stage, we use 840 texts were taken for analyze. The value of FNG metric for main research you could see in table 2. At the first stage of the main research, all available surnames were analyzed. The result of the second stage is the analysis of all texts of necessary authors. The distinctive feature of the second stage is the value of precision and recall metric are calculated only for the text writing by author with a known gender. It's a struct rule because only in this case it's possible to determine the value of needed parameters used to calculate these metrics. So the comparative analytics of the obtained data from table 1 and table from first and second table has showed that the value of all metrics for main research has been decreased. It can be explained by the fact that the classifier makes more error than analyzing a largest amount of data. However, the metric value remained quite high. And like conclusion, we could say that form a set of input indicator. Something happened with my screen. Form a set of input indicator for the resolving the classification task. Conduct the analysis review of approach for resolving the given task. Carry out of review of mathematical classification method and choose suitable method. Done, and develop the model of the gender classification of surname. And like list conclusion, assess the proposed approach of resolving the classification task. Thank you for your attention.
Thank you so much for your presentation. Questions are welcome.
Why didn't you use a neural network?
Sorry, could you repeat your question, because I have not good internet and don't hear part of question.
Neural network. Чому ви не використовуєте?
Why I don't use network? Okay, it's a good task, but we want to use actually native bias classification here, because this classification has very good result if we need to classificate into if we need to have classification in two classes.
Thank you very much.
Thanks.
Any other questions? I do have one now. Is it possible to use this model of gender classification for some other subject matters? Not the surnames, but some other nicknames, proper names, and so on.
Oh, thanks for your question. Yes, of course, it's we could use this model, and we could use the program that we have with the others parts of the name of people, but we need to change a list of ending. So now we have a list of ending to surname. If we change it, for example, to ends of names or ends of something more, we could have classification to with other terms, with other classes.
Thank you so much. Any other questions? Dear participants of the section Natural Language Processing, thank you so much for your presentations, really interesting and promising and fruitful for further research. I believe we might have some other questions following their presentations and full-scale papers, right? We do have the emails for further correspondence and cooperation in case of necessity. Thus, once again, let me express you the appreciation for your participation. If you have any commentaries, any questions, you're welcome. If not, then we will have the summary session taking place according to our program. So we still hope to see you there for the closing remarks on behalf of our dear professors and the organizers of the conference. Thank you so much.